This is GCSE Physics Past Papers Question 10, and Unit 10 is on work, energy, power, momentum and circular motion, and the questions are from June 06 to June 09. So the first question is from June 08, paper 2. Question 1, state the principle of conservation of momentum. And all you need to put in here is that the total momentum before the collision I'm going to write total here, is equal to the total momentum after. And that will get you your mark. You can even just write momentum before equals momentum after, and you'll still be awarded your mark there. The next part of the question tells you that car A is at rest. This is car A here. Car B, travelling 12 metres per second, drives into the back of A. As a result of this collision, the two cars become stuck to each other and move forward as one. So once they're stuck to each other, that means they have the same common velocity. So their velocity afterwards is equal. So the mass of car A is 2,100 kilograms. I'm going to write that in just. So you've got 2,100 here and 1,500 for sorry, I've got that the wrong way around. This is 2,100 here. And this one is 1,500 kilograms. So it says calculate the momentum of car B just before it collides with A. So we're trying to find the momentum of car B, which is this one here. So if we do our calculation, momentum of B, and the way we calculate that is mass times velocity. And so the mass of car B there is 1,500 kilograms, and its velocity beforehand is 12. And 12 times 1,500 gives you 18,000. Now it's a mass times velocity, so the unit is kg, which is the unit of mass. Velocity is meters per second. And so the answer down here, I'm just going to write the number here and the unit underneath it, kg m per s. And so there's a mark for the unit, a mark for the answer, a mark for the working out, and a mark for the equation. Part 3 of the question says, what is the total momentum of both cars immediately after the collision? Now, the total momentum before the collision is equal to the total momentum afterwards. And the only part that had momentum before the collision was car B. Car A had no momentum because it was at rest. And so car B's momentum is exactly the same as the total momentum of both cars afterwards. And so you're just writing down the answer here again, 18,000 kilograms meters per second. And that's your answer. And you should be aware there that it's only worth 1 mark, so it's obviously something from above here. Show that the velocity of both cars after the collision is 5 meters per second. So we know that the momentum before is equal to the momentum after. And we've already got an answer for it. The momentum before is 18,000 kilogram meters per second. Now, the momentum afterwards is a mass of A plus B, because they've stuck together, times their common velocity. And so the mass of A plus B is 2,100 plus 1,500 times V, which we're trying to find out. And so that's equal to 3,600. Equal to 18,000. So to get your answer, all you have to do is divide 18,000 by 3,600. And that gives you an answer of 5. And we'll put in meters per second just to keep the unit correct. So you get 1 mark for stating this. You get 1 mark for recognising that this is 18,000, sorry. 1 mark for adding your two masses together. And then 1 mark for your answer. Part D. Peter, who has a mass of 80 kilograms, jumps out of an airplane. Just just before he opens his parachute, he's falling with an acceleration of 6 meters per second squared. Calculate the resultant force on Peter. So I'm just going to draw his acceleration is 6 meters per second squared. And so calculating the resultant force in him, so you're given an acceleration, you're given a mass, and you're asked for a resultant force, so you have to use F equals M times A. And that is going to be 80, which is his mass, times his acceleration, which is 6. And that gives you an answer of 480 newtons. And so you get a mark for your answer and a mark for your equation. I just realised you can't maybe see that properly. Okay, so then it says calculate the upward frictional drag of the air which is causing Peter's acceleration to be less than the acceleration due to gravity of 10. You're advised to show clearly how you get your answer. Now, the most obvious thing to do here is look at the forces acting down and the forces acting up on him. So the frictional force of the air, that's what we're looking for, and we'll call it F. And then downwards, the force on him is his weight, which is mass by acceleration. So the resultant force acting on him, we now know is 480. And he is falling downwards, so that means this W force must be greater than the frictional force there. If I draw a dot on, this arrow should be slightly longer. So 480, which we've done the calculation on, is equal to W minus F. And we can easily calculate W. W equals his mass times acceleration due to gravity. So his mass is 80 and acceleration due to gravity is 10. And so to calculate F then, what we have to do is bring F over here and it becomes positive, and bring the 480 over here. So F is going to be equal to, multiply this out, 800, and you're taking away 480. And you get an answer of 320 newtons. So 1 mark for your answer, 1 mark for this equation, and 1 mark for your calculation.